Okay, for this next problem, we can see the instructions, find the general solution for this system of equations, and then B, find the particular solution. So that means we can find what A and B are. And then we'll find the long-term ratio of X to Y. I encourage you, if you'd like, to go ahead and try to find these eigenvalues and eigenvectors on your own for part A. So pause the screen and see if you can find those. Or if you want, keep watching. I'll go through it pretty quickly. So I'm going to set the determinant of, not x, sorry, 1 minus lambda, 2, 3, negative 4 minus lambda. Set that determinant equal to 0. That means 1 minus lambda times negative 4 minus lambda minus 3 times 2 equals 0. Make that prettier 4. So what does that give us? Negative 4, negative 1. So we have negative 4 minus 5 lambda plus lambda squared. Let me make sure. No, that's not right. Lambda squared, because that actually is positive 4 lambda. Sorry. So that is plus 3 lambda. You're better off on your own. Minus 6 equals 0. So we have lambda squared plus 3 lambda minus 10. Factor lambda plus 7. No, not plus 7. Plus 5. And lambda minus 2 equals 0. So we'll say lambda 1 is negative 5 and lambda 2 equals 2. You can put your lambdas the other way. You'll get the same answer in the end. So if you're checking this and you wrote the lambdas in another order, that's fine. I encourage you to continue with the problem like so and see if you can get the same final answer. Then we'll have lambda 1, case 1, negative 5. To find the eigenvectors, that would be, I'm going to skip a couple steps here. I would have x plus 2y equals negative 5, or sorry, equals 2x. Sorry, I'm getting ahead of, no, that's right, negative 5x. So I have 2y equals negative 6x and y equals negative 3x. So I'm going to let x equal 1, and if x is 1, y is negative 3. Yep, that's what I have there too. Good. Lambda 2 is 2. So that's x plus 2y equals 2x. 2y equals negative, or equals x, I guess. Yeah, just x. So when x is 1, substitute 1 in for x, y is 2. Did I do something wrong here? When x is 1, oh, no, yes. Okay, I just did what I told you not to do. My goodness, it's late. I wouldn't actually substitute 1 in for x. I was like, something doesn't look right. I would substitute 1 in for y here. I think it's more convenient because if you substitute 1 in for y, 2 times 1 gives you the x, which is 2. Ooh, glad I caught that. All right, and so for part A, the general solution then is the derivative, or sorry, not the derivative, x is equal to a e to the negative 5t times 1 negative 3 plus b e to the 2t times 2, 1. And this is going back again to the formula on the previous page. Good, yeah. Now, part B, we can find the particular solution given that x is 4, y is negative 5 when t is 0. Well, what we want to do is we want to think of vector x as xy again. And then we're going to find the x component. The x component is all of the top row. So that's a e to the negative 5t times 1 plus be to the 2t times 2. So that's b times 2e to the 2t. So I gave the 2 to the top part. And I also have y equals a times negative 3 e to the negative 5t plus b times, what is that? Just e to the 2t, because I'm multiplying by 1, the bottom row. And then what I want to do is substitute when t equals 0. So at t equals 0, x is 4 and y is negative 5. So I can take this, substitute 4 in for x. Well, when t is 0, I simply have a plus 2b. And then y is negative 5 when t is 0. So I'm substituting t in for 0 in for t, which gives me negative 3a plus b. Lovely. We have a system of equations. You can solve the system of equations in your calculator. If you go to menu, algebra, solve system of linear equations. If you want to do that, do that. I'm going to multiply the bottom equation by negative 2, personally. So if I multiply by negative 2, I get this. And then I'm going to add it to the top equation, a plus 2b. The b's cancel. If I add these two together, I get 14 equals 7a. And I know a equals 2. If I substitute 2 in for a, I believe I get b equals 1. Does that make sense? Yep. And then b equals 1. So this is like 8th grade math. I'm not going to go over this in any more detail. And then I have the final answer. I need to rewrite the entire solution, but with a and b, because it said find the particular solution. So I have 2e to the negative 5t times 1 negative 3 plus e to the 2t times 2 1. Let me put a little circle around that because it's getting a bit sloppy. There we go. That's the answer to part B. This was the answer to part A. And now we can look at part C. Part C says find the long-term ratio of x to y. The long-term ratio of x to y. So we want to see as t gets larger and larger and larger, as t goes to infinity, I'm going to move me. I'm running out of room. As t goes to infinity, 2e to the negative 5t goes to what? Well, as t gets really, really large, then e to the negative 5t goes to 0. It goes to 0, right? And so, yeah, am I doing this right? Yeah, it goes to 0. And as t goes to infinity, e to the 2t goes to infinity. And so long term, what's going to happen is this first case isn't going to really matter very much. It's going to go to 0 long term. And so the ratio then, e to the 2t, is the one that, so as this one goes to 0, this part isn't going to matter very much because you're going to have 0 times some stuff here. And not very meaningful, and so, or it's like not going to help us with the long-term ratio. What's going to happen is this part is going to keep growing and growing and growing. But as long as the second part keeps growing and growing and growing, the x is always going to be twice as large as the y. So can you imagine as e to the 2t gets larger and larger and larger, because of the 2 to 1 vector here, the x will always be twice as large as the y. So the x to y ratio is going to be 2 to 1 long term. Ratio of x to y. Take a moment and think about that. I hope that makes some sense to you. If not, we can talk about it in the next class, or you guys can talk about it with each other. All right.